No matter what your business is, whether it's hauling materials on high-speed interstates, navigating on busy city expressways, or transporting the most valuable cargo of all, people, on crowded city streets, it is your equipment that you rely on to get the job done effectively and safely. It's hard to imagine a more vital part of safe, reliable operation than the air brake systems, and that's what this presentation is all about. A typical air brake system can be divided into several distinct parts: the supply system, the front and rear service systems, and finally, the trailer. This presentation is the first of a four-part series and deals with the operation and maintenance of the air supply system. During the program, we'll point out areas of maintenance concern. Although brake systems and components may vary from vehicle to vehicle, the air supply system, shown here in blue, is basic to all. The major components are the air compressor, supply, front axle, and rear axle service reservoirs, governor, and air dryer. The primary component of the supply circuit is an air compressor, such as this Bendix 2-Flow 550. Powered by the vehicle's engine, the air compressor converts atmospheric air into compressed air, energy needed to power the vehicle's brakes. The compressor components we focus on during this presentation are the crankshaft, connecting rods, rear end cover, rear main bearing journal, pistons, cylinder bore, inlet valve, discharge valve, and discharge port. The compressor crankshaft and connecting rods convert the rotational force of the engine to a vertical linear force in the compressor pistons. The compressor is lubricated by pressurized engine oil, which in this case enters the rear end cover, flows to the rear main bearing journal, and through a passage in the crankshaft to the connecting rod bearings. Oil that escapes from around the bearings falls to the bottom of the crankcase and is returned to the engine. This oil return is important because it prevents crankcase flooding, which results in compressor oil passing. Let's take a look at the air compressor from a front view, revealing a single piston only. During the intake stroke, a slight vacuum is created above the piston in the cylinder bore, causing the inlet valve to open and move from its seat. Filtered atmospheric air flows into the bore until the piston reaches bottom dead center and begins to reverse its travel. As the piston begins its compression stroke, the inlet valve closes, and the air in the cylinder bore is compressed as the piston approaches top dead center. During air compression, the discharge valve opens, allowing compressed air to flow from the cylinder bore past the open valve and out the discharge port into the supply reservoir. Returning to our full cutaway view of the compressor, we find that since the compressor contains two cylinders and the crankshaft has 180-degree opposed journals, one piston will be on its intake stroke while the other is compressing, building to maximum pressure. While this is occurring, a constant flow of engine coolant is routed through the cylinder head cavities to dissipate the heat generated by the compressor during air compression. Rapid buildup of air pressure depends upon proper opening, closing, and sealing of both the inlet and discharge valving and unobstructed flow of air in the cylinder bores. Check for any restrictions to the flow of atmospheric air into the cylinder bore or the compressor discharge line leading to the supply reservoir. The obstruction of atmospheric airflow into the cylinder bore will cause the vacuum above the piston to draw oil past the piston rings, resulting in oil passing. An obstruction in the compressor discharge line leading to the supply reservoir will cause the compressor to run hot, build carbon deposits, and pass oil despite adequate coolant flow. Next, let's look at the Bendix D2 governor and how it interacts with the compressor and supply reservoir and later the air dryer. The governor is used to control the compressor and thereby regulate air pressure in the supply reservoir. The governor's main components are the reservoir port, piston, inlet exhaust valve, pressure setting spring, and governor unloading port. An air line connects the governor to the supply reservoir. Reservoir air enters the governor at its reservoir port. As air from the compressor builds reservoir pressure, the governor's piston and valve move together against the resistance of the pressure setting spring. When reservoir pressure reaches the cutout setting of the governor, typically 120 psi, the piston will have moved sufficiently to seal the exhaust and open the inlet. Reservoir pressure flows past the inlet, through a passage in the piston, and out the governor unloader port to the compressor unloader mechanism. Air from the governor enters the compressor and acts upon the unloader pistons, which move and hold the compressor inlet valves off their seats. With the compressor unloaders pressurized, air enters and leaves the cylinder bores through the open inlets, and air compression ceases. Because the pistons are 180 degrees opposed, air is shuttled from one cylinder to the other as the pistons move up and down. When supply reservoir pressure drops to the cut-in pressure of the governor, typically 100 psi, the governor pressure setting spring moves the piston, closing the inlet and opening the exhaust. Air in the compressor unloader mechanism flows back to the governor and is exhausted. With air pressure removed, springs move the unloader pistons, allowing the inlet valves to return to their seats, and the compression of air resumes. Here's a service tip. Make sure the air line between the supply reservoir and governor is unrestricted. Otherwise, the governor's function will be impaired. If either the governor or compressor unloader mechanism fail to function, the compressor would continue to compress air. To protect the air systems against a failure of either the governor or compressor unloader mechanism, a safety valve like the Bendix ST3 is installed on the supply reservoir or air dryer if the vehicle is so equipped. Generally set to open at 150 psi, the safety valve employs a spring-loaded stem resting on a seated ball valve. When reservoir pressure exceeds the valve setting of 150 psi, the ball moves off its seat and air is exhausted through the exhaust port. The safety valve should be checked periodically by pulling the exposed stem. Air should escape when the stem is pulled and cease when released. A dual circuit brake system generally consists of a minimum of 3 reservoirs: the supply reservoir, the front axle service reservoir, and the rear axle service reservoir. The service reservoirs supply both the front and rear axle brake